السلام عليكم ورحمة الله وبركاته، وأسعد الله أوقاتكم بكل خير. السيدات والسادة الكرام والمشاركين معنا في هذا المساء واللقاء الثري، نرحب بكم من الهيئة السعودية للفضاء، والتي لها مبادرات عدة لنشر الوعي في مجال علوم الفضاء. وفي هذا اللقاء، وهو اللقاء الثاني من لقاءات مبادرة سبيس توك، التي فيها إثراء المحتوى التقني ونشر المعرفة الرقمية في المجتمع عبر مشاركتكم في اللقاءات الرقمية، إحدى مبادرات Think Tech. يسعدني أن أقدم لكم لقاء الليلة الذي سيتحدث فيه بروفيسور ديفيد ألكسندر، وهو رئيس معهد الفضاء في جامعة رايس بهيوستن تكساس بالولايات المتحدة الأمريكية. وسيكون اللقاء بعنوان The Changing Face of Space، ويعني تطور قطاع الفضاء. سأعطي ملخص بسيط قبل أن يبدأ بروفيسور ديفيد، ملخص صغير عن اللقاء الليلة باللغة العربية، في حال أنه يوجد مشاركين يعني ليس لديهم إلمام كبير باللغة الإنجليزية، فسأتحدث ملخص سريع. ثم مع أنه الدكتور ديفيد يعني مجهز باللغة العربية بعض الترجمات، فما سنتناوله هذه الليلة سنناقش كيف يتغير المشهد الفضائي من خلال زيادة مشاركات المنظمات غير التقليدية والبلدان الحديثة والقطاع الخاص. كما يمكننا أن نلاحظ أن عصر الفضاء الجديد يتضمن التطور في محاور مختلفة وعدة، منها استكشاف الفضاء. يعني زي ما انتم عارفين الآن استعمار المريخ بتحاول الناس تستعملوا الحدود في حوالي عام 2030. إيلون ماسك صرح أنه حيرسل بحلول 2024، وأنه صرح في 2050 حيكون في تقريبا 1,000,000 شخص على سطح المريخ. المحور الثاني في هذا التطور اقتصاد الفضاء. سيتم استثمار تقريبا نصف تريليون دولار بحلول 2030. الوصول للفضاء سيصبح أرخص بكثير، وهو أرخص من السنوات الماضية القديمة حقيقة، ولكن خلال 10 إلى 20 سنة القادمة سيكون بنسب كبيرة جدا exponentially أرخص. الأقمار الصناعية سيتم إطلاق حوالي 15,000 قمر صناعي في حلول عام 2030. ستستمر المنظمات والهيئات العالمية في ريادتها العالمية للعلوم في الاستكشافات العلمية، يعني في مجال علوم الفضاء. أنا حسأل دكتور ديفيد كيف هذا حيؤثر على هيوستن وكالة ناسا، وإيش التحديات الفريدة التي يمثلها. أيضا سنتناول عجالة موضوع الحطام الفضائي وتأثيره زي ما أنتم عارفين على صناعة الفضاء والأقمار الصناعية وتأثيره عليها واصطدامه وارتطامه بها. وأخيرا استكشاف مأهول إلى أي مدى ستذهب البشرية في استكشاف العوالم الصالحة للسكن خارج مجموعتنا الشمسية، وهذا موضوع يعني آخر موضوع حيكون. بروفيسور ديفيد ألكسندر هو خريج أو serve the director of the Rais Space Institute, where he is responsible for providing vision, direction, and leadership, managing the various institute programs, identifying, fostering research opportunity for the faculty, and interacting with government and the space industry. David, I'm going to talk Arabic and English, so please tolerate me. So طبعا بروفيسور ديفيد هو صديق وزميل منذ جامعة، درسنا سوا في جامعة كلاسكو في اسكتلند، وعنده علاقات قوية مع هيئات الفضاء سواء في ناسا أو في إيسا، ويعرف الكثير من رواد الفضاء ما يقارب 50، وله صداقة كبيرة مع سمو الأمير سلطان بن سلمان، وسبق زارنا هنا في كاكست في جدة. أيضا he has served so many professional committees، يعني كان شريك في كثير من الكوميتيز واللجان including NASA Advisory Council, Heliospherics Subcommittee, and NASA Solar Heliospheric Management and Operations Working Group. وآخر حاجة طبعا قائمة طويلة جدا في السي في البايو تبع الدكتور ديفيد، أنا ذكرت فقط مقتطفات سريعة. He was recently appointed the chair of the inaugural Aerospace and Aviation Industry Committee for the Greater Houston Partnership. Dear David, I was talking in Arabic and explaining what are we going to talk tonight. So inshallah, we'll have 45 minutes for your talk and then 50 minutes for discussion. So kindly, can you start? Thank you very much.
Shukran. Thank you, Yassin. All right, I already have my first technical problem. It looks like my my earbuds are running out of power, so I will take these off.
Okay, no problem.
Can you hear me, Yassin?
Yes, clear.
I had to switch my audio. Well, thank you, Shukran, everyone. I know it's kind of late in the afternoon where you are. It's late in the morning where I am. It's always great to see my old roommate from Glasgow, Professor المليكي, and hear how he's doing and how his family are doing. So what I want to do, so many of you who follow perhaps the space industry know a lot about what's going on perhaps in certain areas. And so each one of those areas could take a long time to talk about. So what I'd like to do today is just touch on some of the topics and give you a little flavor of how they kind of fit together. But then perhaps if there's an interest, we can go more deeply into some of those topics in the Q&A. So I would very much encourage you to put your questions in the chat or the Q&A, whatever Yassin said to you in Arabic. Please follow those instructions. And as you can see, I'm using some software that does live translation. I just want to let you know that I am not responsible for the translation. And so please excuse any errors. Some of these, I'm from Scotland, and sometimes my Scottish accent can
Looks
cause
great, David.
disruption. Okay. So the picture you're looking at is, many of you are probably familiar with it. It's a dummy called Starman that Elon Musk decided to stick in one of his Tesla Roadsters and launch into space. And it'll be orbiting Mars for like 1 million years or something. And while this is a little bit of a PR job, a little bit of self-promotion and so on, it does capture the notion that we are changing our approach, particularly in the United States, but also, as I'll talk about, around the world, in what we mean about accessing space and who is accessing space. And so I'm going to talk a little bit about that first from the perspective of NASA, and then a little bit more generally as we go forward. So hopefully these slides will move forward as I go. What I wanted to do, and I heard Yassin discuss a little bit about what we do at the Space Institute at Rice University. So I won't spend too long on this, but I just wanted to introduce the Space Institute to you. One of the things we're just celebrating 21 years. I've been the director for 9 of those. And in my time, we have gone from being just purely education and outreach to more research and industry connections. And so I have 2 parts to my job. One is to promote the research that's happening within our university out into the broader world, to NASA and to the space industry, particularly around in Houston. But I also, part of my work is to also look at what Rice is doing, some of the technologies that Rice is participating in, most of which is not for space. It may be for the medical industry, it may be for the energy industry, it may just be sensors for monitoring people's health or so on. And so what I try to do is look to see what exciting research is being done and how it might be useful for space. And so then I try and work a partnership between that faculty member and, again, perhaps NASA or some of the other space industry people around us in Houston. So those are really the two parts to that. We also, of course, it's a university, so we focus very much on our students. And we have a very active student chapter who do, in fact, we'll be launching our first ever student satellite in April. We won a competition and NASA selected our mission, and the students are building that as I speak. We also have a group of students working on another NASA challenge, which is to develop a human-powered rover for the moon. And so these are challenges that student teams from around the country and in some cases around the world participate in and have a competition to see who can provide the best technology. And the great thing about that is that it gives the students not just experience in the technology, but experience in putting a team together, doing the programmatics, fundraising to pay for what they need to do, doing the timelines, the kind of thing that we would do if we were building and designing and building a real space mission, the kind of thing I used to do when I was at Lockheed Martin. So we have a whole range of different things on the education, on the student engagement, and of course, on the research and the engagement with industry. In that context, what I wanted to bring up with you as you think about space in Saudi Arabia, because space, a lot of people think of space basically as somewhere you stick a satellite. But really what it is it's an application of technology. And of course, in Houston, we have the world's biggest medical center. We are regarded as one of the energy capitals of the world. And of course, we have the NASA Johnson Space Center. So we are very, three important industries in Houston are space, energy, and medicine. But instead of thinking them separately, what we try to do is think of them as technology applications. And I'll talk about this a little bit later too. So what this means is that a technology, for instance, to monitor the health of an astronaut, which may be developed by NASA, may actually have a real use in the medical center for monitoring patients, perhaps who have difficulty traveling to their doctor or difficulty traveling to the hospital. These technologies, which we obviously, an astronaut can't just leave and go visit the doctor anytime. And so we have to have these remote technologies or on-site technologies that help monitor and take care of health. So there are many, many different technologies. I'll mention some of them later, where the application may be designed for a space application, but the main market, if you're thinking about commercialization, will be on the ground, for the humans on the ground or for technology on the ground. The same applies with energy as well. We have a series of events that we host over the year, which looks at what we call crossover technology. So for instance, one of the areas we focused on was imaging technologies. And as you're well aware, in Saudi Arabia, of course, energy is a very big industry. Medicine and healthcare is very important. And you're growing your space interactions as well. And the key thing is that all of these communities need to be talking to each other, because a solution that gets developed in one industry very often stays within that industry and no one else knows about it. And it's important that those technologies be out there, that people in the space industry, people in the medical industry be aware of relevant technologies coming out of the energy industry. And I'll name some general areas as we go a little bit later. So I think that's one message I would like to give you as you start thinking about your involvement with space, given your foundation and where you are already in what you have been doing in Saudi Arabia, for example, in the kingdom there, in other areas. And so the more we do this, the more efficient and effective we will be in each of these. So that's my big message. The rest is just fun and nice pictures, but that's my big message.
Excellent.
This is an example of, as we start to think about this changing face, and I'll emphasize some of these things a little bit later. Now, what I've done here is I've got two parallel tracks. And the top track is just a number of potential space technologies, space applications, space structures. And you can put your own names in there. You might have your own favorite technology. You might disagree with me on what the time frame is. I often say that if you're talking about space technology and you put down a time, then you're either lying about the space technology or you're lying about the time. So I've just tried to make a guess in here, but you may move some of these around to different timeframes. You may put different technologies in. You may think other technologies are more important.
Mm-hmm.
But what I've done is, obviously we're very busy with small satellites and constellations at the moment. So that's one example in the short time horizon. And of course, we're looking to Mars settlement, sometime in the next 30, 40, 50 years. We'd like to develop systems that generate power in space that can help the power on the Earth, the energy issues on the Earth, and all sorts of range of things like this. So that's one message that you can take from this. The other message is the parallel development on the ground. The parallel development that helps support those technologies and also applies them on the ground. And so we have this parallel line. And again, I've tried to do the same thing. In the short term, what are we looking at? Well, again, you can add your own thing, but obviously we're looking at uncrewed aerial vehicles or drone technologies. How can we better use drones for different purposes? Monitoring our borders, looking at helping agriculture, monitoring shipping, helping shipping in the shipping channels and avoid collisions, all these different things. We're also interested in low-cost access to space, and that's something we'll focus on. That's where Elon Musk and Jeff Bezos and those guys come into play.
Yeah.
And particularly, we're looking at satellite applications and how we can use satellites to better our lives here on Earth. And then as you go up in time, you can bring in things like hypersonic flight, where we're interested in point-to-point transportation, where you can, I remember when I flew to Saudi Arabia from Houston, it took a long time. If we could do that in 2 hours, because of hypersonic space travel, where you go from Houston spaceport to a spaceport in Riyadh or somewhere in the kingdom, that really revolutionizes business communications and travel in general. Of course, it has to be cheap and it has to be safe, and that's why the timeline is a little bit further out. And then ultimately, we can think about things like space elevators, which is the ultimate cheap way of getting to space if we can develop the technology. And again, I just want to point out that you can add in your own favorites in here, but the key thing is these parallel developments. In order to do the things that we think we want to do in space, we have to support that with an equivalent development on the ground. And so these things go hand in hand. They're not separate. We often get criticized about why are we spending money in space when there's so many problems to solve on the planet. But we don't spend the money in space. We spend it on the ground, right? There's not an ATM in space. There's not a Starbucks on the moon where we're spending money in space. It's all being spent on the ground to develop technologies to employ people and hopefully to benefit our knowledge or our ability to sustain life and improve life on the Earth. So again, that's another broad message I would like to get across. Okay. So what I'd like to do, is basically give you a quick, I'm not going to go through all of this, but obviously one of the biggest organizations when it comes to space exploration is NASA. Now, I'm being a little bit biased here because I'm in the United States, but of course, a lot of the work that NASA has done has been in partnership with countries around the world. Russia is a big player in space, of course. China is a huge player now. India is growing. And then we're seeing countries like my own small country, like Scotland, United Arab Emirates, Saudi Arabia, Luxembourg, Portugal, Italy. All of these countries are starting to think about how they can get involved in space and how it can benefit their economies and their people. And so this is an exciting time, but I would still argue that if there's a name that comes to mind when you think about space, it's NASA. And so I wanted to start a little bit with NASA because this changing face of space is in part being driven by NASA and changes that NASA have made in the last 5 or 10 years. And of course, you've probably all heard of this. And again, you notice I've got 2 dates, 2020 and 2024. And remember what I said earlier? If we're talking space and we're talking dates, you either believe one or the other. You don't believe them both together. So we don't think have humans on the moon. I don't think we'll have humans on the moon by 24. I'd be optimistic for 26 or 28. But the timeline that NASA was being pushed towards was 24, which I think is a little bit unrealistic. However, development has been happening rapidly, and they've been selecting contracts to do cargo delivery using commercial companies for cargo landing. They're working with SpaceX and with with Boeing and Lockheed to develop the Orion spacecraft and the Space Launch System to get the big rocket to get humans to the moon. And so they've called this Artemis because Artemis was the twin sister of Apollo. And of course, Apollo was when we first went to the moon back in the late 60s. And so this is just a timeline. I don't want to read it all to you. You can find this at NASA websites. But essentially, and we're already a little bit behind on that first one, but the first Artemis flight is going to be a human-rated spacecraft. It will not have a crew, but it will be a human-rated spacecraft. And the idea is to take that to the moon and bring it back and test all the systems. Artemis 2, which will hopefully be there soon after, will have humans on it, but will not land. It will do a pass around the moon, very, very close to the surface, and bring those humans back as another test. Then there'll be a series of missions that will provide the infrastructure that the actual astronauts, the actual crew, will need when they get to the surface. You know, things that can generate power, potentially things that can provide energy, you know, and things that can maybe work on the early stages of what we call in-space resource utilization, using what's on the moon to help you sustain your presence. That means potentially, at least first, it means mining water from the perpetually shaded regions, permanently shaded regions in the craters, particularly at the South Pole. Okay. And to take that water and to turn it into hydrogen and oxygen, which is rocket fuel, or to use it as water. Right. Lots of different purposes of it. And so there will these be the support. Now, this slide is a little bit out of date because it talks about a gateway, which will be an orbiting station around the moon called Gateway. That's still in the plan, but it was removed from the critical path a couple of years ago. The idea would be that you would not launch from the Earth and land on the moon and come back. You would launch from the Earth, go to the space station, and then take a landing system that goes from the space station to the surface and back. So that's a bit simpler, it's a more complex architecture because there's more parts, but it's a simpler architecture when it comes to the difficulty of being able to launch from the Earth and land on the moon. And so that was the purpose. That has been changed a little bit. And NASA just recently, you may have heard the news, NASA recently funded sole source with SpaceX to produce a human landing system directly from the Earth. That is now on hold because Jeff Bezos, all these billionaires fighting with each other, Jeff Bezos has a lawsuit in place because he felt that the selection was unfair. So that's an ongoing discussion. We have a company at the Houston Spaceport, and I'll talk about the spaceport a little bit later, that is building one of these landing systems and have already got 3 or 4 missions in mind and clients with scientific experiments and so on. So this is very exciting. The key point in this context of today's talk is 10, 20 years ago, the way NASA would have done this would have been very different and far more expensive and less innovative. They would have gone to their usual contractors and, maybe Boeing and Lockheed or United Launch Alliance, which is a combination, and they would have done one-off systems. And NASA would own it. NASA would say, I want a lunar lander. And here's what we want you to build. Here's what we want it to do. And once you've built one of them, it belongs to us and you're done. Thank you very much. Well, now the new model is we don't want a human lander. We want to rent or lease or buy a ride on a human lander. So we will work with you as a commercial company, whoever you are, if you've got a good idea and good innovation, Intuitive Machines, Astrobotic, some of these companies you may have heard of, SpaceX, of course, and Blue Origin. And what we will do is we will give you a contract for the development of such a system. But you're free to innovate. You're free to put in, as long as you meet our standards for safety and reliability and all those things. We want to keep our astronauts safe. You can design your own system, and when you're done, it's yours. So now you have a system that you can make your own contracts with a rocket launch company. You can talk to Yassin Amliki and say, hey, would you like to fly to the moon? Okay, Yassin, oh, sure. And they say, okay, it'll cost you $20 million. Yassin goes to his bank, gives them the $20 million, and then he gets to go to the moon. So that allows these companies to actually be commercial companies rather than contractors. So now we have a very vibrant commercial space industry in the United States, and we're seeing that commercial industry grow around the world. In the China, Japan, Europe, in the United Kingdom, there's some commercial companies, I believe, in the Middle East who are working. And so this is a changing approach. It's a more innovative approach. It is truly a commercial approach where these companies can sell their technology, they can sell their services, and they can bring in multiple clients. The key thing for NASA to pay for it and NASA to buy the seats on the spacecraft is, of course, it has to meet their standards, and those are very high standards. So even though this is it looks like a NASA program, we're going back to the moon, it is very different from what it was back in the day, back in the 60s. And as usual, when it comes to space, I talk too much, and so I'm already behind time. So let me move ahead. These are just a couple of the companies that were selected for what's called CLPS, Commercial Launch Payload Services. Orbit Beyond were selected and then had to pull out because they didn't think they could meet the deadlines. And there's a second stage of companies already been selected as well. Intuitive Machines here in the middle happens to be based here in Houston, at the Houston Spaceport, which I'll talk about a little bit later. And then again, I'm not going to read all of this, but just to give you a sense of now that I've transitioned into this changing face of space, which is the commercial component, there are now financial marketing companies and trade companies and venture capitalist monitoring companies who are taking an active role in monitoring these industries. And what you're looking at here is a small subset of commercial companies that have risen, and some of these names you'll recognize. I'm looking for, I'm not sure if SpaceX is in there. Relativity Space you may have heard of recently. SpaceX is over there on the right. And so some of these you may have heard of, but most of them I suspect you will not have. But these are all companies who are getting money. They're getting investment money to develop their technologies to do something with or in space. And that's something we would not have seen, at least to this extent, 15 or 20 years ago. Now, at the moment, most of these companies are to do with service providers of data from Earth observing satellites. And we'll talk a little bit more about that in a second. That's the biggest chunk of the market right now. Your GPS, your pictures of, your maps. Yassin just told me he looked up Google Maps for where Rice was relative to Houston. These are all services that are provided from space. And there are more and more companies providing high resolution data, imaging data, spectral data, radar data, for financial services, for GPS, for tracking, for environmental monitoring, for operational monitoring, a whole range of different purposes. And that is the biggest chunk of the market, not the rocket launches, not the satellites, not the in-space stuff, but the data that those systems provide. And then we can see this again. This is from Seraphim Capital. Now, Seraphim have only been around a few years in the space business. And they're now growing to, I think there may be maybe a couple of $100 million of investment. And so they're starting to bracket, and you'll recognize these if you're familiar with the energy industry. You've got your upstream and your downstream sectors. And so that's everything from building instruments to launching those instruments, to providing data. And you can see on the bottom, there are already a number of companies who are looking beyond Earth. What can we do on the moon? What can we do on asteroids? What can we do when we get to Mars? So this is a really exciting time. It's a transition that's happening quite dramatically. Again, I would point to the fact that the US has got a big lead in this, but that lead is narrowing as the years go by, as people see the benefit and see these things working. And so now there's a whole range of commercial companies springing up everywhere. So it's really exciting time. Again, quickly, some of the ones you've heard of, SpaceX. If you get a chance to, I won't show the movie, it takes too long. But if you can go and look at that movie, I watch a lot of science fiction movies. Nothing is as impressive as watching these two things land together. And remember what we used to do, if we wanted to launch a payload to space, the payload is tiny, the rocket is big. We burn up all the fuel to get to space. We launch the payload and we throw everything else away. It's expensive. Everything burns up in the atmosphere, we dump it in the ocean, it's expensive. No longer. Companies like SpaceX and Blue Origin are now, and Virgin Galactic are developing reusable systems. So each part of the rocket, other than the fuel which you burn, and the payload which has got to its destination, they are working to repurpose every other piece of that rocket. And that does two things. It brings the cost down. It doesn't bring the cost down as much as you think because you're reusing that piece again. In other words, you don't have to build another one. That saves you maybe $10, $15 million. But where you're saving the most money is instead of having to build another one and wait 4 months for your next launch, you can clean this one up, fix out the dents, give it a coat of paint, and you can fly it 2 days later. And so as you start to increase your ability to go to space more frequently, as you know, if we only had one flight between the Middle East and the US a week, it would be a very expensive thing. But now that we have multiple flights per day, you can bring the cost down. And this is what's happening with SpaceX. They've been very successful. This is their reusable boosters. They just satisfied their commercial crew opportunity. So this is Shannon Walker, who graduated from Rice in 1998 doing space physics. This is the commercial crew, and they had the demo one, the crew one, and crew two now. So they've proven to be very successful, and you may be following a lot of their explosions. They're building Starship, which is a huge, if you can see this image, you'll see that, let's see if I can, this is their current Falcon 9, this is Starship. We're now in the realm of science fiction here, but this is actually, they're working at, they blow it up, they learn what the mistakes are, they fix it. And this is turning into a viable system to the extent that NASA has, even though it has never flown, NASA has kind of selected this as potentially a lunar capable rocket. And then, of course, we've got Virgin Galactic, just because they were in the news about these billionaires in space. They have a reusable system. It's a rocket plane that basically gets taken to altitude by a fairly large but irregular aircraft. And then it drops and fires its rocket engine. They've had some problems over the course of the last few years, but now they're back on track, and this is Richard Branson flying in his own spacecraft.
What was the height, David? David, what was the height? What was the height they reached?
So this one is, so these are suborbital, and there's the big pillow fight between Blue Origin and Virgin Galactic is Blue Origin goes up to about 80 kilometers, which is technically space, but Blue Origin goes to 100 kilometers, which is the Kármán line, and a lot of people think that's really space. So you can argue one way or the other, but it's definitely suborbital, and it's focused on space tourism. You can now buy a seat for $450,000 if you can afford that, and go on one of their future flights. More importantly, as they've developed these technologies, there's a spin-off company called Virgin Orbit, which is similarly to, if you're familiar with the Pegasus missions, you basically carry a rocket up under the fuselage of a 747 or some other large plane. You get to altitude, you drop the rocket, and then the rocket has the capability of getting you to orbit. that is where the market really is, I believe, because it's about launching satellites. And as I pointed out, that's what the big focus is data from satellites. So again, you can look into this in more detail. You can see, you can have your own opinions about space tourism or satellite systems, etc. We also at the Houston Spaceport, we have a company called Axiom Space. And what they are doing, and again, you can go look up their website and see the extended version of this video. They were given a contract by NASA to develop the first private space station. And so they're developing this system. They will initially be connected to the ISS, the International Space Station. And then once they've got all the components, including their own power and communications, etc., they will separate from the station. And they are promoting this. They're taking astronauts up to people who want to be private astronauts. They've got a cupola, as you can see at the bottom there, if people want to go up and just have a view of the Earth. They're developing scientific stations and so on so that people can do research and do commercial development up in space as well. So again, this is a change. This is now a commercial entity trying to do business by being in space. And so that's, again, an exciting proposition. I don't really have time to go into this, but as you think beyond this, as we think about going back to the moon and having a sustainable presence in the moon, you can imagine a whole industry. And we call this cislunar development. So cislunar space is the orbit of the Earth, the space between the Earth and the moon, the orbit of the moon, and the surface of the moon. And so now there's active discussions going on about once we have this presence at the moon, how can we create an actual space, an in-space industry? If we mine water, we can bring that water up from the, or as I said, we can use solar power to break it into hydrogen and oxygen. We can bring those gases or those liquids, depending on the temperature, up into lunar orbit. And we can create gas stations. We can essentially have a depot full of oxygen and hydrogen. And so when you are thinking about maybe going to Mars, now you don't have to bring all the fuel out of that very deep gravity well, which is the Earth. You can bring up just what you need to get to the moon and refuel at the moon and go on your way. And so there's a whole range of things around this as to what we might do. As we do this, can we build more things in space? Can we build solar panels that can provide power? Can we put industry on the moon so that we don't have to have heavy industry on this planet, and we can therefore help the environment? A whole range of different discussions going on in here. And those all require new and in some cases unproven technologies. And this is where the develop comes in. You can see solar electric propulsion, which is something that is being in-space propulsion technique that is being promoted across the world. Solar electric propulsion is really slow, but that doesn't matter if you've got a constant flow of spacecraft in this thing here. This would be the tug. So you would put something on this spacecraft would slowly orbit and just continually orbit between the Earth and the moon. And you would have a whole bunch of them. You launch your spacecraft, you stick something on here, and it carries it transports whatever you need to the space station around the moon, to the habitat on the surface of the moon. And so these are starting to become serious conversations as to how we can have a truly in-space industry, not just a space industry, but an in-space industry. And again, and you can make up pretty pictures about how that might look when you're on the surface of the moon and so on. There's even technologies where they're looking to producing effectively a concrete from lunar surface material, lunar regolith. And so you basically put robots up that create landing pads, that create roadways for future infrastructure going up there. Whole range of really interesting and clever ideas that are not, they're expensive, and we're talking maybe 30, 40, 50 years, but from the point of view of technology, they're not that far away. It's just, is the market there to put this kind of level of infrastructure up on the moon? And that's what we're trying to develop. Again, a big area that I could spend a lot of time talking about, but I'll try not to, and that's this notion of in-space servicing. if you can put this infrastructure in place, you can do things like, and I think, let me move on, because I think I call it the 4 R's, right? So now what you're looking at is you have all these resources in space. You have your telecommunication satellites, you have your weather satellites, you have your reconnaissance satellites, you have your environmental monitoring satellites, you have your astronomy satellites. Those can be expensive and they can run out of fuel, and they may need to be refurbished and so on, which can be expensive if you have to do it from the ground. So typically we just let them die. Well, now there's a growing conversation about how we can reuse those and keep them up for longer at less expense. And so I call it the 4 R's. You can reuse. So for instance, if you have one of the biggest chunks of space debris when it comes to mass is old Russian second stages. These are just big empty canisters. And so what you could do is repurpose those, reuse those. You could seal them and turn them into a module, turn them into a habitat, turn them into a tank for storing liquid oxygen or something. You can refuel. You can bring this liquid oxygen from the moon, go up to a satellite and refuel it so it can have another 20 years of life at geostationary orbit. Of course, you can repair the satellites. You can harness that, grab the satellites and fix maybe their power system, replace their solar panels, etc. So there's various things you can do with repair. And of course, one of the biggest topics at the moment is remove. Space debris. We're putting so much things up there that it's becoming a hazard to doing more in space. And so what we want to do is develop technologies that will allow us to remove pieces of equipment that are or defunct satellites. So all of this is happening together. All of these things, you can read some other things there, are happening in the context of what we're doing to change how we access and how we work in and with space as we go forward. And this is the kind of thing that we can generate. We can go to space to benefit the Earth. So instead of focusing on space, we focus on what we can do for the Earth. And I've mentioned this already. One of the biggest chunks, this is, if you look, this is a bit old now, but it's the numbers are a little bit different, but the percentages are roughly the same. Small part of the space market is manufacturing satellites. As you go to supporting those satellites with launch services and ground stations, it gets bigger. But the biggest, by far, biggest chunk of the market is the services. This data that you're providing, this information and knowledge that are being used to make businesses more efficient, to make our life more convenient, to support online shopping in the case of a pandemic, etc. And so that's the biggest chunk. And so I tried to put that in there. And again, for the sake of time, I won't spend too much time on that. And again, I put this in, I did this before for Norway, actually, for some folks in Norway, who of course are another big energy country, but I thought I would just grab it for an energy country like Saudi Arabia, just to show you, and you're probably doing some of this already. There are ways that you can use data from space. It's not just about pictures, it's about communications, it's about intelligence, situational awareness. It's about understanding the operational environment you're in. Is there a flood coming? Is there some other natural disaster? Is there a problem, a sandstorm that's maybe interrupting your transportation? All of these things can be monitored and in some cases predicted, and therefore mitigated, since you have this information. And so you can do this for the maritime sector, you can do it for the energy sector, you can do it for transportation sector, you can do it for fishing, you can do it for all sorts of things. That data is already there, and better and more and better systems are going up every day. So again, this is an important aspect to think about as you go forward. So this is what I was alluding to earlier. When you think about these crossover technologies, and again, you can put your own list in here, but there are some technologies that are specifically needed for space, right? If you're going to put an astronaut on a space station, you need to be able to provide reliable power. You need to be able to reclaim as much water as you can so that you're not constantly having to fly water up, whether it be for drink. I mean, the astronauts joke that yesterday's coffee is tomorrow's coffee, right? Because they're reclaiming about 94, 95% of water that the astronauts use, and a lot of that is from waste products. You need medical diagnostic devices that are non-invasive. You have to be able to take care of astronauts in space, and that leads to things like tele and robotic medicine. All of those technologies can be used on the ground. If you have a good water reclamation technology, why not use it on a farm to avoid irrigation costs and the abuse of water? All of these things can be used on the ground. Then you think of a lot of the things that are being developed for applications on the ground that could maybe be applied to space. Artificial intelligence, machine learning, virtual reality, augmented reality. Recently, we've had a lot of concern about mental health because of people being isolated and being stuck at home. And mental health can affect things like human performance, cognitive function, all which are important for humans working in the extreme environment of space. And so those technologies that are being developed to help us here on the ground can be translated over to a Mars mission, for example. And of course, nutrition and food processing, that's another thing. If you're going to Mars and it's a 500-day mission, you have to prepare the food 3 or 4 years in advance, pack it, send it off, and have it edible and nutritious for the astronauts 5 years later. That is a technology in its own. And the key point I want to make, even though I've put these two things as a list, they're interchangeable. There are technologies in artificial intelligence and machine learning that are being developed specifically for space. Those technologies can be translated back to the ground. So again, you can make your own list, you can put them in any column, but the key point I'd like to make is it's just technology. And the technology will have more applications. Almost any technology will have more applications than the one you designed it for. And it's always good to keep an eye out for that, as I guess is my main point. Okay, I've got 5 minutes or so left. In order to support all of this activity that we've just talked about, the commercial activity in space, we have to have a ground infrastructure that helps develop those technologies, connects those technologies to the people who need them, and support the application of those technologies and get them into space, support them in space, and so on. And so one of the growing areas in the last few years has been the idea of a commercial spaceport. Now, in the United States, we have 12 commercial spaceports right now. Houston Spaceport was number 10. There are spaceports. Portugal's looking at spaceports. Italy's looking at spaceports. The UK is looking at 4 spaceports. Australia's looking at them. I think they're looking at one in Dubai. All around the country, India, China, the whole place, they're looking at the development of these spaceports. Some of them are government, some of them are closed, but others are commercial. And so as a result of that, what we did was a few years ago, we created a thing called the Global Spaceport Alliance. And we were having an annual summit in Houston where we had all of the US ones represented. And increasingly, we were having representatives from other countries. We had, I think, 7 different countries represented at our last one, including Italy, Australia, Japan, and Ecuador as well, actually. In that Spaceport Alliance, we put together the thing called the National Spaceport Network Development Plan that we passed on to the United States government to help them, the Federal Aviation Authority, to help them think about how they can support this growing industry. We happen to think that Houston is one of the best ones because we cannot launch rockets. We're in the middle of a huge city with 7 million people, so we cannot launch rockets at the Houston Spaceport. But what we can do is we can launch Virgin Galactic, for example. We have a horizontal launch license, but there's not many companies doing that at the moment. So instead of waiting for them, what we are doing is building an infrastructure of space technologies around the spaceport. And if the launch company wants to come and join us, they're welcome to do that. And so what we have a company developing a lunar lander. We have the company developing the commercial space station. We have, let me jump to here. So we have Intuitive Machines who are developing the lunar lander as well as drone technologies. We have Axiom Space, and these are all facilities that are currently being developed. They're building these, they're investing the money to build these facilities right now. So Intuitive Machines is already there. Axiom Space is building their facility. Collins Aerospace just signed a deal. They're opening a 116,000 square foot facility, including some space allocated for a space incubator and accelerator. Venus Aerospace is a hypersonic flight company who are looking to join us. And around that, we're also looking at developing an educational component. So we have already got the Edge Center here, which is a community college, is putting together with industry support programs to create the aerospace technician that they need. People who can handle composite materials, people who can do avionics. So these are kids coming straight out of high school, getting certified to go work in the space industry. And more broadly, because Rice is a big a tier 1 research university, we're working on a bigger picture, which is the Center for Research Education and Workforce Development, which will integrate the workforce development side of things with the training, all the way through to the professional development, recruitment, and PhD research at the top level universities. We're in the process of putting that together right now. So it's a very exciting time. And I think if you see any of the news, you will see that Houston Spaceport is taking a lot of getting a lot of praise for the way that we're going about our business here. We have partnerships around the world. So this is Arturo Machuca, who is the general manager of Ellington Field in the Houston Spaceport. This guy just retired recently, but we have an arrangement with Prestwick in Scotland, partly because of my connections there and being my home country. But the picture I have for this is that we will develop the Houston Spaceport that will take advantage of all of the strengths that Houston has. We have NASA, we have the energy industry for technology, we have the medical center for technology, we have one of the most active ports in the country for transportation technologies, we have a lot of great universities. All of these different things happen around here. But we also want to partner to the other spaceports within Texas. Texas is a large state. So Boca Chica, where SpaceX is, Midland has a spaceport, but also through the Global Spaceport Alliance and connect to the US spaceports and as well as the international spaceports. Each one of these spaceports, they don't have to look like Houston. They will have their own local expertise, local capabilities that they should build on. And so this is really not about everybody looking the same, but taking advantage of the local strengths and then partnering with everyone else to fill the gaps that they have. And so I call this thing SpaceWeb. If you've ever talked to NASA, you know you have to have a good acronym. So I've got SpaceWeb up here. And we can talk about that a little bit later. So in the last couple of minutes, I just want to talk a little bit about the international side of things. And again, this infographic that I'm showing here is really focused on the moon, but there's a lot more countries, including your own, around the world who are looking at different aspects of the space world. But just even for the moon in the 21st century here, these are all the countries that are looking to put missions in, on, or around the moon. And so this is really an exciting time. The NASA has a thing called the Artemis Accords, where they are trying to get people to sign on to this kind of peaceful use and sustainable use of space. I believe the number of countries now is up to 19 or 20 that have signed on for this. And so there's some debate as to what this really means. But I think if we are going to succeed in space, with all the things I've just talked about, it has to be an international endeavor. Space is not owned by any one country. You can put a flag on the moon. It doesn't mean you own the moon. And so we all have to work together and then support those developments for the benefit of all of us here on the planet Earth. And that's where the conversation is going. So I'll finish with, I think I've kept to time. Well, let me go back a second with a quote that summarizes this commercial aspect. To solve problems on the scale of space exploration, we need the infusion of innovative thinking from across a large number of disciplines, all of which, if designed properly, can also apply their solutions to the Earth. So this is technology development, which will enable a whole range of applications, including those in space. And with that, I've never kept to time in my life before. So with that, I will stop, Yassin, and hand it over to you. And thank you all for your time. And I'm happy to some questions.
Thank you very much indeed, David. It was excellent talk, marvelous. I love it. I have lots of questions on my WhatsApp and on the screen. So if you can bear this with us. I mean, one of the points that I would like to mention, that the changing face of space or the future of space is tremendously changed. I mean, it's exponentially, as you explained in this wonderful talk. And it has lots of, you know, the reusable system, the Axiom Space, the cislunar, and the commercial commodities. I mean, the people who are entering, the private sector who are entering are very much encouraging. One of the questions, David, was asked by, what role do you think Saudi Arabia will play in future global space missions?
Well, I mean, I think that's very much up to Saudi Arabia. I think that there are many different opportunities. I think one has to be careful not to do too much, or at least propose too much early on. You need to have a strategy that takes advantage of your strengths, and you have a lot of strengths, that feeds that into not just the technology development, but also the educational component, because you need that next generation to come forward and build upon what you already have and what you're trying to create. I think many smaller countries in the space world are thinking a little bit more about the satellite market. And some countries might be focusing on launch capability. Scotland, I'll give you an example from Scotland, because I work very much with them. And Scotland is a country that's part of the United Kingdom, of course, but it's a country that only has about 5.5 million people. But they have decided that this data services is the main area to focus on. And so they are putting government investment into initially into that data. How do we produce products that allows Yassin to buy our data to do something he wants to do in his daily life? And if you have a lot of Yassins around the world, you make a lot of money. So it's not just about producing the data. You have to be clever with it, because data is useless if you don't convert it to information. And so some people, I mean, it could be as simple as a young innovator who develops apps for the iPhone, deciding that he can tap or she can tap into space data and tell Yassin that the supermarket has 5 parking spaces, so he better get there soon. I mean, it could be anything like that. You don't have to be a space person to have that idea. And so, but you have to develop the culture, and you have to develop the support infrastructure to allow those ideas to come forward and be supported. Not all ideas are good, but you want to be able to have a range of ideas where you can select the good from the bad, and then develop that further. So that's one aspect. Scotland has decided to go a little bit further. And now they actually, Scotland, Glasgow, my hometown, and where Yassin went to school for his PhD, Glasgow now produces more satellites in the world than any city outside of California.
Oh gosh.
Outside of the West Coast of America. Okay. And that was a strategic investment. Now, they're all small sats, they're all CubeSats, as you're familiar with those. But that, so now they have a growing and one of the best CubeSat satellite markets. They have a growing and one of the best data markets, and they want to build a spaceport so they can also have a launch capability. So they will have, eventually they will have launch, they'll build the satellites, they'll launch the satellites, they'll use the data from those satellites. And that is a strategy. They're not interested in sending humans to the moon. They're not interested in, they may be interested a little bit in space tourism, but they're really focused on, this is where the economy gets driven. And what I've been talking to them about is, as you do that, again, those technologies can be used elsewhere. So I've been talking to Aberdeen, which is a big oil and gas city, about how they can convert some of their ideas over into space technologies. And so you broaden your market. So I think Saudi Arabia is in a similar position. They're at a very early stage where they can basically be smart about what they do. They can look at what's going on around the world in large countries and small countries. They can decide what's of most benefit to them, and they can work to develop that system. And, you know, just be smart about where your strengths lie. And, you know, and where you've already made investments, the medical world, obviously you've got technology from the energy world and so on. So there's a lot that can be done. And I'm a big fan. I know sometimes politics becomes a real problem, but international collaboration is important. You can learn from other countries. You can partner with other countries to broaden your reach and to strengthen what you have already. So again, I could talk at length about all sorts of different little things, but hopefully that answers just generally the kind of question. I don't want to tell you should do this.
Yes, absolutely.
Because in order for me to say that, I would need to know far more about where your investments lie already and what you're thinking. So it's no point me telling you, you have to do, you know, you have to build a lunar station. You have to do that. That doesn't make any sense necessarily. So I don't want to say something specific. I wanted to give you a sense of where you would need to come from. So hopefully that addresses the question.
Oh yes, thank you very much. There is lots of questions actually. I know, David, you've been working a lot on exoplanets and interested in space exploration. How far are we from manned exploration to the nearest Goldilocks planets? You know.
A long time. There is some. So the nearest star to the sun is Proxima Centauri, which is a little bit over 4 light years away. So it takes light 4 years to travel there.
Exactly.
And we know it has a planet around it. Now we've done some work, some research, which I talked to you about in my last talk, that kind of suggests that Proxima Centauri B, the planet, is not really habitable. The conditions are not good for life. But if we wanted to visit a planet just to see what other planets look like, that would be the one. Now, 4 years we cannot travel at light speed. We're nowhere. So I'll give you an example. Some of your younger listeners might not be familiar with this, but the Voyager spacecraft was launched in 1977. So that's 44 years ago. 44 years. I'm old enough to remember it. You're old enough to remember it.
Absolutely.
In that time, it's been traveling constantly at roughly 40,000 kilometers an hour. So that's once all the way around the Earth in 1 hour. It's been traveling at that speed for 44 years. And it only recently left the solar system.
Exactly.
Right? So we are not going to the stars anytime soon. Now, there is some ideas from the Breakthrough project, where the idea is to send a very small payload, a camera, and a solar sail, and push that solar sail with a very high-powered laser. And the hope is that spacecraft, very tiny, not humans, nowhere near humans, that spacecraft will weigh a few grams, 100 grams maybe. It would maybe get up to 1/10 the speed of light. Gosh. If it does that, it would get there in 40 years, and it would send its information back 4 years later. So we would wait so in our lifetime, perhaps, 44 years, if they launch today, we might get the first images back 44 years from now. And that's traveling at 1/10 of speed of light that we cannot do with any real mass right now. So I think we're a long, long way from visiting in person. Now, we can visit these planets with data. We can observe them. James Webb Space Telescope might be able to look at some of the information from these planetary atmospheres. Radio information can tell us about the magnetic fields. So we may be able to at least visit the planets through telescopes. But it's a long, long way before we're flying the galaxy, as like in Star Trek or Star Wars.
Yes, absolutely. Absolutely, David. I mean, Voyager 1 and 2, they are only 17 hours and a half space-wise, and you need 44 years to to visit this planet. Another question, David, regarding the debris, the space debris. You know, there are a huge amount of millions of pieces out there orbiting the Earth with a very high speed, 35,000 kilometers per hour. How NASA and you guys in Houston, as well as the Department of Defense Space Civilians Network, currently dealing with this matter? How do you deal with it?
Well, the way it's dealt with, and again, this is where the commercial side becomes important. The way, maybe I'll stop sharing so we can have a slightly different, the way that NASA has dealt with this in the last several years is if you launch a spacecraft, you have to have a deorbit plan, right? So when we launched spacecraft with Lockheed, you have to build in a deorbit plan. It could be 20 years, 25 years after launch. Okay. But with the launch of CubeSats now, with all these small satellites, and with Elon Musk and launching the satellite network, the constellation network for Starlink for communications, and another company, OneWeb, thinking about doing this, and a Chinese company thinking about doing it. The predictions are that we could, within the next 5 or 10 years, we could have 100,000 satellites orbiting, in addition to everything else that's there, all the space debris and all of these other things. And so there's a really, and that's a problem for us, because if any one of us messes up, it ruins it for everyone. And so there's some complaints about anti-satellite weapons testing that the Chinese did, the US did, India, Pakistan, I can't remember which one, I think India did. Those just create huge clouds of debris that are a real problem. And it basically shuts down space for all of us. So this is turning into a real problem. And somebody pointed out the DART mission in the chat. There are a number of concepts in play for how we might, for instance, you can technically go and magnetically connect to a satellite that is no longer, and either reorbit it or deorbit it. It's a little bit more challenging to sweep up little chunks of material. That's a little, people have talked about large nets, all sorts of different things, but there are a lot of really interesting concepts out there. The challenge is really how big space is and how difficult it is to move around in space. It's not like, I don't know if any of you have watched the movie Gravity, where Sandra Bullock uses a fire extinguisher to fly around space. It doesn't work like that. You don't just say, oh, I need to go down there and fly down there. You have to use orbital mechanics. You're orbiting the Earth at 17,500 miles an hour. You have to get to a position that's maybe orbiting at 17,450 miles an hour, right? So you don't just, you have to worry about gravity. You don't just think about moving around. So in space propulsion, the solar electric propulsion type technologies, the plasma engine type technologies, they have to come into place so that you can actively, it's no point creating a piece of junk to remove a piece of junk. And so you actually have to have these things be able to move around in space. So there's some really interesting concepts out there. A lot of people are thinking about it. To my knowledge, there's a mission going up, and it might be the DART mission. I'm sorry for not having this at my fingertips, where it's a demonstration mission that ESA is supporting, and Lockheed Martin is pushing a mission to try and test these technologies in the very near future. So again, I maybe not be as fully up to date on that as someone who suggested it in the chat, but this is an active area of research and an important area as we develop this low Earth orbit economy.
Yeah, excellent. David, lots of questions, but I know you have to go for some very important visits. So we might invite you again to continue this marvelous, excellent talk. Lots of people are asking lots of questions, but we can postpone it to another time. Thank you very much, David. Indeed, it was a very fruitful talk.
Well, I'm glad there's so much interest, and I'm sure you can answer most of the questions, Yassin, if I have to go. And I just realized that by shutting down the share, that meant I wasn't doing the translation. So perhaps maybe people didn't fully understand what I said. So I should have kept the screen share going. But thank you for your interest, and thank you for the invitation. There's a lot of really good stuff happening, a lot of exciting stuff happening, and there's a lot of room, no pun intended, there's a lot of space for everyone to participate. Different age groups, different levels of skill level, different disciplines, artists, graphic designers, communicators, all the way through to engineers. So
sorry, there is one guy, he want to ask you a question. Is it okay?
Sure.
Yeah, please go ahead. Go ahead, Abdullah. Abdullah?
Yeah, he's on mute.
He's on mute, huh? No, I think he has a problem with his mic, maybe. He wanted to ask since ages. But
maybe he could type it into the chat.
Yes, if you can type it into
the audio is not working.
Any question you can type into the chat. Go ahead. Lots of people are thanking you, David, for this great lecture, and they are interested to see you again. There is a guy asking about the DART mission.
Right. Well, that's what I was saying. I don't know all the details. I should have, because I always get asked questions about space debris. But I would look it up. The DART mission is an exciting concept, so it's worth looking at. I just don't know the details about time or when it's flying, etc.
Yes. Great, excellent. Okay, thank you very much, David. Take care.
Okay.
Have a good time. We'll be in touch again.
And if there's any kind of important, questions in terms of connections and stuff, you know how to reach me.
Oh, absolutely.
Well, again, thank you, everyone. Shukran, and good luck, and enjoy the rest of your Saturday evening. Thanks for taking the time to.
Thank you. Same to you, David. And there will be a translation.